Hi, welcome back to LeetCode. So in this video, we discuss LeetCode problem 3627, maximum median sum of subsequences of size 3. You are given an integer, uh, sorry, given integer array nums with length divisible by 3. Okay, that means it will be like 3, 6, 9, right? All these sizes are possible. The input size, input length of the input array nums. You want to make the array empty in steps. So in each step, you can select any 3 elements from the array, compute the median, and remove the selected elements from the array. So 3 length actually, I have to remove 3 elements in each step. Suppose I have removed x, y, z, these 3 elements. Now what will be the median? So median of odd numbers, here actually odd number, 3 actually odd numbers. First of all, sort this. Suppose after sorting I got x, y, z. This is sorted. So we know that for median of an odd array, the median will be the middle one. That means our median will be y after sorting. So this will be our median for this in these steps. Now we have to return the maximum possible sum of the medians computed from the selected elements. Okay, so suppose in this example 1, our input array is 2 1 3 2 1 3. Now what is the length? Length here actually n is equal to 6. So I have to do the how many operation I have to do? 2 times, because in each step I can remove only 3 elements. So how many actually steps will I required? I required 2 steps, right? So first of all, I can remove any 3 element. Suppose I have removed these 3 element. So 2 1 3. So our answer initially is 0. So before removing these 3 elements, I have to know the median of this array. So first of all, sort this array, then the median will be 2. So answer will be added by 2, and this 3 will be eliminated from the removed from the array. Next, suppose I have chosen these 3 elements, these remaining 3 elements. So 2 1 3. So first of all, sort this 1 2 3. So the median of this array is 2. So our answer is 4, and this 3 element will be removed from the array. So I do not have any more elements. So our answer is, if in this I removed all those 6 elements, our answer will be 4. But our target is to maximize this answer, means maximize the sum of the median. Now this is the brute force like the mathematical observation I have to do to maximize the sum of median. I want to know that I can remove actually 3 elements, x, y, and z. So to calculate the median, I have to sort this. Okay, sorted array. Suppose I got actually, after sorting, I got actually x, y, z. So I know that the answer will be y. So ultimately, what actually our answer will be added is y, not x, not z. But I know that the y will be always the second largest element, right, within these 3 elements. So suppose I actually have 1 2 3 4 5 6. So our target is to maximize the sum of median. So I know that our answer will be added, y will be added only into our answer, right? Y will be only added. So I know that I have to sacrifice x and z. It will not be added our answer, but I have to sacrifice that, those 2 elements. So which it will be better to sacrifice? Like I will actually sacrifice 1 the smallest element, 1 the largest element. Then this 5 will be added our answer. So this is actually the efficient approach. What? Sacrifice 1 smallest element, because x anyway will be removed, z it will be anyway it will be removed, but x and z will not be added into our answer. Only y will be added. So then actually I can choose the 5 in our answer, because this is the second largest. Got it? So what the logic that what actually I have to do? That sacrifice 1 smallest element, sacrifice 1 largest element, and answer will be added by the second largest. Got it? So after this, our array will look like 2, 3, 4, and our 5 will be added into our answer. Clear? Now similar way, what have to do? Sacrifice the smallest element, sacrifice the largest element, and add the second largest element into our answer. So 2 will be sacrificed, 4 will be also sacrificed here, and 3 will be added our answer. So 5 plus 3, so 8, and after this our array will be empty. Clear? Let's see another example for this. Let's see. So for this first example, 2 1 3 2 1 3 2 1 3. Okay. So first of all, sort this array. So this will be 1 1 2 2 3 3. So what is your target? Sacrifice one smallest element, one largest element, and add this into our answer. So our answer will be added with 3. Okay, previously it was 0, 0 plus 3, it is 3. Next, our array will look like 1, 2, 2. That means, what I have to do again, what I have to do in each step, sacrifice the smallest element, sacrifice the largest element, and add the second largest into our answer. So 3 plus 2, it actually 5. Just match with, check with the answer, yeah, it is 5. Let's see another example. 1 1 10 10 10 10. Okay, so this is already sorted, no problem. So 1 1 4 times 10, yes. So our initially our answer will be 0. So what is your target? Sacrifice the smallest element, sacrifice the second largest element, and add this the second largest into our answer. So 0 plus 10. So this logic is clear. Why actually I am sacrificing the smallest element and sacrifice the smallest largest element, because then only I can actually, this will be our y, this will be our x, this will be z. Clear? Anyway, I will not be able to add x and z. So to maximize the sum of median, so our target is try to take the as much maximum value actually I can take. So then actually our target is to take the maximum y. So can actually take this 10, not possible, because there is no more element in the right side. So if I take this, anyway it will be again, it will be converted to z. Clear? The right side element 10. So that's why I know that this will be anyway removed. So next, the remaining element, the largest remaining element will be 10. So y will be added to this. Next, the remaining elements are actually 1, 10, 10. Again, sacrifice the smallest element, sacrifice the largest element, and add this into the our answer. Then it will be 20. Just match, check with the answer. Again, it is 20. This is clear. So this is clear. What I have to do? So first of all, sort the array. Sort the array. Then take two pointer L and R. L is pointing 0, R is initially pointing with n minus 1. That means x, y, z. L is here, R is here. I know that L will be sacrificed, R will be also sacrificed, and our answer will be added to. So I have to continue till our, I actually have still 3 elements. So R minus L greater than equals to 2. That means index 0, 1, 2. So that's why R minus L greater than equals to 2. That means we actually still have some 3 elements. 3 elements actually I have still. So that's why our answer will be added to what? Answer will be added to nums of R minus 1. And R will be shifted to minus 2. L will be shifted to plus 1. This is clear. Why actually R will be shifted to left side of 2? Because this 2 will be removed. Y and Z will be removed from the right side. Next available index will be R minus 2, R minus 1, it will be Y, and R minus 2, it will be again this is next Z2. This is typically Z1, this is Z2. Clear? And L will be shifted to plus 1 because I have removed the smallest element. Next smallest element will be in the L plus 1. So suppose actually the case x1, x2, y1, y2, z1, z2. So our L1, L is shifted pointing here and R is pointing here. So answer will be Z1 means R minus 1, and R will be now shifted to here and L will be shifted to here. Clear? R will be shifted to the left side of 2. This is actually minus 1, this will again minus 1, that's why I am actually adding minus 2. Similarly for the left side, left pointer, it is pointing on the right side of this, so this is plus 1. Clear? From the image it is clear how actually getting the shifting the pointer, and also how actually maximizing the sum of median, because our target is to take the as much maximum number so I can actually take, but to what is the maximum number I can take, that will be the second largest, because the first largest element will be anyway, it will be actually Z, and it will be not be added into the answer, right? Got it? So now go to the code. So first of all, this is a long answer. I have written long type, so that's why I have taken a variable answer of long type. Initially it is 0, and I have to know the input size. And first of all, sort the input array. Now I have to take 2 pointer. One is pointing at the left pointer, pointing at the index 0, another right pointer is pointing at the index n minus 1. So we have to continue till actually we have still 3 elements still present in the array. So that's why R minus L greater than equals to 2. So that means we actually have 3 elements in the present in the input array, in the current array. So our answer will be what? Which number will be added into our answer? That will be R minus 1, not R. That means n minus 2, not n minus 1. R is pointing at n minus 1, but R minus 1 means n minus 2. The largest element will be anyway removed, and the second and the smallest number it will be removed. So that's why our answer it will be, y will be what? R minus 1. That means 3 pointer L, there are 2 pointer L and R. Ultimately, which 3 number will be removed? L, R minus 1 and R. This 3 number will be removed. So what is the y? The median will be this. Got it? R minus 1. So that's why I'm adding this R minus 1. And L left pointer will be shifted to plus 1, and the right pointer will be shifted to minus 2. Left side of this 2 index. Got it? And ultimately return the answer. What was the sum of the median? Got it? This is the maximum median. I have shared this in the description. And if you have any suggestion, any doubt, you will comment on that. And if you found this video useful, please like the video. And if you are not yet subscribed, please subscribe the channel. Thank you.